Welcome back to Office Hours Unplugged, where we chat with the most prominent researchers and PIs here in McMaster. Today, we finally have Dr. Yingfu Li joining us. It's a pleasure to finally have our own PI here on our show. Could you please introduce yourself to the audience and let them know a bit about yourself as a McMaster?
Yeah, it's great to participate in your show. I was really looking forward to this. I'm a professor at McMaster University, and I've been here since the end of 1999. So it has been quite many years for me. I did my undergrad in China. At the time, China was still quite backward and so different at the time. And so then I motivated to pursue, high degree after undergraduate study. So I did a master's in part of Beijing University's well-known university in China, but they had an agriculture college. Eventually, that college became China Agriculture University. That university focused on all kind of research related to agriculture. So at the time, I was kind of interested in changing how pesticides were made. So I wanted to make green pesticides. So that was my focus as a real researcher at that university. And then I also learned that to advance further, then I need to go pursue a degree in a Western university, because it at the time appears to be much better system to acquire research skills. So that's how I ended up in Canada. I did my PhD. Then I went to U.S. For my postdoctoral research, and went back to Canada and got appointed as a professor at McMaster University.
Wow. And your postdoctoral work, where did you do it in the U.S.?
It's Yale University in New Haven. I spent 2 years there. From 97 to 99. I worked with a hugely talented scientist about my age. And I learned a lot from him. And part of that learning experience made me feel that I want to pick, independent research career like a professor. So that was quite eye-opening experience for me.
So did you always know you wanted to do research? Because it sounds like you had an idea.
No, honestly, when I grew up, I want to be a writer. I want to write stories. That was my huge passion, and it's still my passion at this moment. So I enjoy writing, and I can write nonstop for hours and hours. And but I grew up also like science. Science perhaps is a second choice for me. So I was very, very good in science, all the subjects. Mm-hmm. And eventually I feel that picking a career as a scientist can change the world, and it can make a huge impact. And also allow me to be creative, and something I really appreciate. And being a writer, you're creating stuff. Then being a scientist, you make discoveries. You create stories based on scientific discoveries, and you write papers that will have long-lasting effect for future generation of scientists. So that's why I'm very much interested in science for a long, long time.
So it's like a combination of both your passions, right? Like research and sciences, and then you still get to write.
Yes.
And it's very...
I think it's, as a professor, it's like a dream job.
Right.
And, it's we have to write grant proposal. And you may or may not know that I'm actually quite a competitive person. And being a professor, you need to be competitive. And you need to get the funding. Then the funding success rate typically like a 10 to 30%. So that means a lot of people will get rejected. Nobody wants to get their proposal rejected, but that's the reality. Then the same with scientific publication, and it's a peer review process. And so all these combination, right? So science is really, you make discoveries, and you propose and test ideas with experiments or other means, and then you write about stuff. So I think that combination is really a perfect fit for me. So that's why I'm totally absorbed into my work. It just really has just made my life very meaningful.
I actually really liked that thing you brought up about how discovery is incredibly incentivized in scientific research. I was actually saying this to someone the other day. I think this is like probably one of the few fields in the world, next to the arts, I guess, where curiosity and creativity are incentivized and actively encouraged. And I think it really keeps your work fresh, if that makes sense. It doesn't get monotonous.
Yeah, I agree 100%. And the reason we pick science or doing research, scientific research, is really there's so many mystery out there in the natural world, right? From as big as the universe and as small as cells. There's so many things that we don't know. And then not only we don't know the things at this moment, we also don't know the history of this, like origin of life and how the universe was created, right? And I read and listen to things about like Big Bang for so many years, and it would just fascinate me. And it's just so many things like in science you can get very excited about.
So then why did you decide that, you wanted to look at functional nucleic acids, right? Because you mentioned you did a little bit of research in agriculture. So why the shift towards nucleic acids?
That was actually a very interesting story. I came to Canada with the dream of becoming a top organic chemist. I told you that I got trained in Beijing Agricultural University, where I actually synthesized many potential molecules that can be used to green pesticides. And I want to learn from top scientists how to make that process more efficient. So that was my original plan for pursuing a PhD at Simon Fraser University with someone, I don't know whether he's still around, Cam Oschlager. But when I came to Simon Fraser University, he was not around for probably our entire months. And there was a young professor who just joined SFU, Simon Fraser University. His name is Dipankar Sen, and he's very well trained. He got a bachelor's at Oxford, then PhD at Yale, and then went to Harvard to study for Wally Gilbert, who actually invented the chemical sequencing method, got the Nobel Prize for that, and shared with Sanger. We talked about in our class and focusing on Sanger sequencing, but he actually developed the chemical sequencing method. So Dipankar talked to me multiple times. He really wanted me to join his lab. It's because that at the time, nobody knows whether DNA molecule can be catalytic. So we all know the protein can be enzymes. That's what all these wonderful molecules in our cells are doing that. And prior to our work, there was discovery made by Thomas Cech and Sidney Altman, who is Canadian. Their work showed that RNA has been another unique class of macromolecule in cells, and you know very well, they can be enzymes, we call ribozymes, right? We talk about this in the 2B03. But Dipankar want to see if DNA can also be catalytic. So he was looking for somebody who has synthetic organic chemistry skill to help him to realize his idea, because he want to synthesize molecules that mimic transition state of a chemical reaction. That's how natural enzyme does. Like it interact, bind the substrate, and then really turn that substrate, go through the transition state to lower the energy to allow the reaction to occur. So then he told me at the time, I didn't know too much then, is that if you can get an aptamer that bind to transition state analog, TSA, and that DNA enzyme might be catalytic. So I was fascinated by that idea. And so then after multiple conversation and then Professor Oschlager came, I said, if you don't mind, I want to join the Dipankar Science Group and to pursue this new idea, which is so fascinating to me. So that's how I got into the catalytic DNA, or in general, the functional nucleic acid business many, many years ago. That was in 1992. So many, many years ago.
And you mentioned aptamers. So is that your first exposure to aptamers as well?
And so then the first things I was tasked to do is to make an aptamer bind to a whole bunch of molecules that mimic the transition state of 3 different reactions. So so my first thing is to create a library, doing the selects, and looking at the sequences that bind to the TSA, the molecules that mimic the transition state. And one of my 3 projects worked out well. And so one of the molecules that isolated bind to a compound called N-methyl mesopofrin, which is a transition state mimic for porphyrin metallase, porphyrin methylation reaction, which in our cells, like a heme, is an important molecule, right? So the heme is a porphyrin that has an iron sitting in the middle. And there's a protein enzyme called the ferrochelatase, insert that iron into the ring of porphyrin. And so basically we're making an enzyme and doing the same chemistry. So that was my PhD work.
Wow.
And it was fascinating. And I had a lot of failures. And so I started the work in 92. My first paper was not actually published until 96. And so my first 3-4 years, like a total struggle. One, I have to switch field. So my English at the time was not that good. So I have to ask my wife to buy biochemistry. Because I told you, like the textbook in Chinese, so I cannot make up the the knowledge in biochemistry. Anyway, it was that was the beginning, and then a lot of failures, troubleshooting, just like you guys are doing right now. But eventually, I overcome all these challenges and find that little magic DNA molecule that do porphyrin methylation.
That must have been very, very satisfying to finally encounter that success after years of struggling, I assume.
Absolutely.
Yeah.
you're always worried about your future, right?
Yeah.
And particularly, I give up everything. I have a decent job in China,
Yeah.
and I have a family, and then I have no idea whether that whole process paid off.
Mm.
But from my experience, that actually was a very good experience for me because I overcome that. Now, I don't get worried about anything, right? So, you know, it didn't kill me and it made me stronger. That's exactly what's.
Wow.
Yeah.
And that experience, you know, with aptamers and the satisfying results at the end, was that what led you to create the lead lab and like focus on aptamers?
Yeah. So then I wasn't sure, right? So I came to North America. My original plan was, okay, I get my degree and I get some research experience. I will return to China and doing my research over there. So then, so the two things really changed my plan. When I find the research in Canada at the Simon Fraser University was much high quality, and all the setup was great. So it will make me more productive, and it's easier to do a scientific project then. The second thing is, in my culture, also the system I came from, it was less free to do stuff. And I find, okay, in Canada, it was completely different. So the freedom that I enjoyed when I was a student, I find that this is something that I want my kids to have. And so and then that's the motivation for me to change my plan. Then I know, okay, I definitely want to be a professor, but I wasn't sure I was good enough. And, my English was not that good, and even now my English is probably still bad. But they start to really, the success of my PhD study really gave me better confidence. And also my supervisor kept on telling me that you're a talented guy, and you're one of the talented guy I know. And then he think, yeah, you can make it. And so then I would study, okay, how people get a professor job in a Canadian university. So now I know that I need to do a postdoctoral research. I needed to find somebody who could teach me more. So I decided to looking for a few labs to see if I can find a research position like as a postdoc fellow. And it's a long process, but in the end, I ended up at Yale University to work with Ronald Breaker, which was such a positive experience because by the time my skill was excellent. Mm-hmm. So with Ron, I learned a whole bunch of things, like his passion for science, and then his writing skill was amazing. And it's the clarity of his thinking. Like, he knows exactly what he's going after. And I work hard at Yale University, probably my hardest working years. And then I made pretty good progress. And so I work on 4 different projects, and all of them actually work out. And so I end up with publishing 4 research papers and a couple of reviews within 2 years.
Wow.
And so at that time I said, okay, I'm ready. So here's the story. So one day, Ron discussed in the group meeting. We have like group meetings quite often, just like we have right now. And he said to us, I don't know whether it's in response to a question we asked or not, but he said someone should establish their own lab if they start to question their professors. And then I followed him to his office. I said, as you know, that we have arguments all the time. So I think I want to looking for a professor job. Ron immediately said, no, that doesn't apply to you. But joking aside, and he said, yeah, I would like you to stay here as long as possible, but I won't also stop you from pursue your dreams. Yes. If you think you're ready, yeah, go ahead. So then we'll start looking for jobs, and then I end up with, got the job at a McMaster.
Wow. That must have been...
Yeah. So something is really, it's go for my dreams, right? So I feel that I'm not ready. And as I said, I'm a competitive person. And I just feel that if I got the opportunity, I can establish a very competitive lab. And so that's why. Although I clearly worried. But I think at that time I would think I was maybe 70% confident that maybe 30% worried.
Yeah, and you think that your PhD kind of gave you that confidence? Wow.
Yeah, that's one. The other thing is that I've seen the other scientists. I work with Dipankar and work with Ron. They're all talented, without question about it, but I also feel they struggle as well. Not all their ideas actually worked out. And not like as a scientist, you figure out everything. No. And you probably find out in the lab that's not the case. But if you keep on trying, then you'll succeed. And we have enough knowledge, we react to the results and make changes in our research plan on things that we're going to work out, just like everything. So, that's, all these experiences make me feel that I'm ready and, I will be successful if I'm dedicated to my work and then keep on trying and apply whatever we learn to the job. And on top of that, being in Canada, even if I failed, the Canadian government have paid me employment. Maybe I can get trained to be a cashier at Walmart and doing stuff like that. So
it's always a good fallback.
Yeah, there's always have something. And I think that one of my friends ended up with car salesman.
Oh wow!
And he make more money than I do. So there's always, as you know, that I have pretty decent personality. So I think I can be in sales, right? So.
Well, just zooming out here, I mean, throughout your PhD and then your postdoctoral research, you were mostly doing research on your own. You were managing your own projects. Becoming an independent investigator now, that probably comes with its very own unique set of challenges. Yeah.
That's, I think I'm a good observer. And so I observe how my supervisors did with regard to mentoring others and how to build relationships. They also, it's very compatible with me. Although I'm a scientist, I'm really a people's person. I like, have fun with people. And in research, collaboration is part of it, right? And so at a McMaster, I counted, I probably have collaborated with over 30 people. And many biochemists in my department, I collaborated with them, right? And so, it's a kind of, that type of, I guess a phenotypical trait that I have, make me feel I can manage, right? Yeah. And there's also, we grew up, right? So we get trained as student and then a researcher, a postdoc fellow. And by the time I feel that I have the organization skill, and then I have interacted with many and I'll also be able to read them, and all these things will make you, and it's give you the phenotypical traits to make you successful. That's what I believe, that I'm not worried about whether I can manage a lab.
Mhm. And what was like the vision for the lab? Because you had this experiments with your PhD and then post-doc work in Yale. So did you kind of want to follow up on that work, or did you kind of want to take your own approach?
I want to stay in the field because I was one of the original scientists that actually created that field. And at the time, there's very few people working in this area. So I feel I'm dying to expand it.
Mhm.
So, but every lab has the focus, belongs to their lab. So I decided to focus with my own thing because with Dipankar and Ron, we are really trying to test theoretical aspects of functional nucleic acids. So when I set up my lab here, even though that years was still my interest, but I want to expand to things like disease diagnosis, making the functional nucleic acids as important tools. And I don't believe anyone at the time had that motivation, because people just play with the DNA, have fun. I want actually to expand it into some tools that could help us, in medicine or whatever. So that was my vision. And when I was interviewed, I said, still remember, I said, if I got the opportunity, I want to be remembered that I was the one in the world who make the most of the DNA enzymes. 2, I want to be, every time that people come up with something, some application, they will actually come to me. And I think I have done both. And so some of the funding that I got, like what Sana and Jimmy Guo is working on, I didn't originally pursue these ideas. I was introduced to other researchers by my friends who was originally asked to do that research.
Right.
And he said, he's at Columbia University, he said, you got the wrong person. You should contact my friend Yingfu Li at McMaster.
Oh,
So they
nice.
contacted me. And
Wow.
so we wrote a proposal. Okay, we got to fund it. And so I think that's something is always like I feel so proud, right? And something that I feel that I can, I contributed to the growth of my field, and also not only put myself as a leading researcher, but it's really put McMaster in Canada on the map, and show that we can do cool stuff that might one day, help Canadians and help people around the world.
I mean, you are the go-to researcher for anything functional nucleic acid related, as far as I'm aware, which I think you've definitely established yourself in this university, and I think in the country, as one of the leading people.
I'm not as overconfident as the president done the thoughts there, but yes, I'm fully confident. I'm very well known in my community, and also beyond my community, and a lot of collaborations that actually come from beyond my community, right? So like I'm working with people, Professor Leila Soleimani, who is not in my community, and she's just interested in aptamer thing and using it as a sensor, but she's not really doing aptamers, functional nucleic acids. And there are many things, the same thing. And the collaboration I have right now with through Jim with researchers in the U.S. They
Mm-hmm.
were not in my community, right? So
Right.
so I just feel that researchers really open up a lot of interesting relationships, interactions, and that it's just a fun thing to do, right?
Yeah. And do you think that functional nucleic acid research as a whole is beginning to grow in popularity nowadays?
There are a lot of challenges. To be honest, I think is that yes, overall, the field has been growing tremendously, particularly academically. There's just so many research publications. At the beginning, I remember every publication. Now, even I do research, I won't be able to find all the publications.
Yeah.
So, for that sense, the field has grown, tremendously. But in terms of the real applications, commercial diagnostic tests and drugs, we're still limited. That is something that I'm not very satisfied.
Mm.
And so I go to conferences and meet new researchers, always, tell them that. Because it's important. It's not like just demonstrate the proof of concept. We needed to make efforts to generate fantastic aptamers, fantastic DNA enzymes, so that they can be applied to real world applications.
Mm-hmm.
So that is something that I have been promoting. And as you know, then in my lab, we're doing that, right?
Oh, yeah.
So we're making fantastic aptamers. I try to get my team to go with me and develop methods that everybody can make this aptamers that can beat antibodies or even not in comparison to antibodies. Because we can do evolution, we can do all these things. So in theory, that we should be able to make fantastic molecules, then take over part of the world or
Right.
biological world. And I think eventually it's going to happen. And it takes time. And when you get more and more people doing it, the chance to have bigger impact is bigger.
Oh yeah.
And so I'm very hopeful that in the next few years, like 10 years, I think, there are significant developments in terms of applying whatever we learn in academic labs into commercial successes. So that, we can make functional nucleic acids for treatment, diagnosis, environmental monitoring, everything that you could imagine, right?
It's interesting you brought up those applications. Which one of those do you see as the more a likely one that will start being more widely, that will widely incorporate the use of functional nucleic acids like immediately?
Well, obviously, I think diagnostics it has a lower requirements to enter the commercial world. The drug discovery is everybody's holy grail.
Oh yeah.
And but in an academic setting, it might be difficult because you need billions of dollars to get it done, and we don't have that kind of cash money. But diagnostics, I think, the threshold and moving from academic lab into companies is lower. So that's what I think, particularly for things like SARS-CoV-2, influenza, or the next pandemic. That's what I'm hopeful. And so we'll make the technology ready. Now, don't get me wrong, I don't want these pandemics to come, but I'm not an expert on that. But if you listen to experts, these things were going to come. And so in my case, I already know the original SARS, and then SARS-CoV-2 will also have, other similar things like Mexican swine flu.
Mm.
Right now, we are a little bit worried about H5N1.
Yeah, the avian.
Yeah,
influenza.
avian flu virus. So these things can all happen. And so I just feel that if we make the technology ready, just like a Moderna, right? So when SARS-CoV-2 is here and they make the vaccine, and not only the company did exceptionally well, they really help people.
Mhm.
So I envision that the functional nucleic acids should be able to do the same thing. We put together a quick diagnostic test when the companies take a very long time to get it done, and we might be able to set up the initial test, get to the people's hand very quickly, or in the centralized setting, but for schools and airport and senior homes. Right. If we can do that, we can make a difference. We can save lives, right? So those are the things that I feel the diagnostic things that we have been focused on in our own group and also elsewhere. May be able to make that breakthrough into the commercial world when the time is ready. But again, we needed to have that greater principles established so we can react pretty quickly for situations like that.
And given those concerns, is there any research? I know our lab is doing so many different types of projects, but is there a project in particular you're very interested in and are hopeful to see good results from it?
Yeah, the ones we have been working with, Leila's group on the electrochemical sensing, and with John Brennan's group on lateral fluid device, through people like Amal and Connor and Jimmy Marr, and also departed NELAB members, and also Leila Soleiman's group. We are all make the technology ready. We do research to debug the process so that when the time is there, our technology will be plugged in and we can get it done in days and weeks, a month, instead of waiting for years to get it done.
Right.
For a pandemic, we won't be able to find a good time for that. So that's my motivation. I think that's why we're focusing on all kind of infectious disease, because infectious disease can kill you, not necessarily kill like you or me, and we're very healthy and we don't have complicated medical conditions. But we have grandparents, we have the society have people who might have compromised, immunity. So in that case, they do need to have fast protection.
Right.
And that's what I hope. Every life, there's a reason for them to come to this world. And so it would be good to protect the life. And if we can invent technology to do that, I think the meaning of life and meaning of a scientist, that's, I'm not just saying this, but that's deep in my heart.
Brilliantly said. I completely agree, and I think Aus, you completely agree as well.
That was very well put. This has been a very truly enriching conversation. Thank you so much for coming down here and speaking about this. I hope all of our listeners here learned a lot today. I know I sure have. This has been Dr. Yingfu Li from the Biochemistry and Biomedical Sciences Department. Dr. Li, thank you so much for sharing a little bit about your science with us. And thank you to everyone listening. We'll see you next time on Office Hours Unplugged.
Great. Thank you so much.
Yeah.